If you've ever worked with Cisco's application-centric infrastructure, you know that policy is, well, it's everything. But as your network grows, trying to manage all those contract relationships between your endpoints, it can turn into a real nightmare fast. So today, we're going to break down a super powerful feature designed to solve this exact problem. It's called vzAny.
All right, here's what we've got on tap. First, we're going to talk about the contract scaling challenge, why this is even a problem in the first place. Then we'll introduce our hero, vzAny, and see how it simplifies things. We'll peek under the hood to see how it optimizes policy, run through some real-world use cases, and wrap up with the really crucial rules and limitations you've got to know.
So let's set the stage, right? In the ACI world, nothing talks to anything else unless you explicitly allow it with a contract. These contracts define the rules for traffic between different endpoint groups, or EPGs. Now, in a small setup, that's pretty simple. But what happens when your environment starts to get big?
This picture right here, it shows the problem perfectly. On the left, you've got one provider EPG, maybe it's a file server, that needs to offer a service to 3 different consumer EPGs. To make that work, you have to build out and manage 3 separate contract relationships. Now just imagine this isn't 3 EPGs. Imagine it's hundreds, or even thousands. Yeah, it gets messy, complicated, and honestly it's just asking for human error.
So how in the world do you solve this scaling nightmare? Well, lucky for us, Cisco ACI has a really elegant answer. It's a powerful object called vzAny.
So what exactly is vzAny? You know, the easiest way to think about it is as a kind of wildcard or a shortcut. It's this special object that represents all of the EPGs inside a specific VRF. So instead of applying a contract to every single EPG one by one, you just apply it to vzAny once, and boom. The policy automatically covers every EPG in that VRF, even the new ones you add 6 months from now. And this slide right here, this is where you really see the magic. On the left, that's the mess we were just talking about, all those individual relationships. But look at the right. That's the vzAny solution. The provider EPG has just one relationship to the contract. And on the other side, vzAny acts as the consumer, basically standing in for all the other EPGs. It's just clean, simple, and so much easier to manage.
Now, this simplification isn't just about making things look prettier on your configuration screen. Nope, it has a huge impact on the hardware itself. So let's look under the hood and see what's actually going on and what the real benefits are.
Okay, the biggest benefit here is that vzAny saves a ton of space in a really critical, really expensive piece of hardware memory on your switches called the policy TCAM. TCAM, or ternary content addressable memory, is this super specialized high-speed memory that stores all your policy rules. I like to think of TCAM as the VIP section of the switch's memory. It's incredibly fast, but seating is very limited. Every single policy rule needs a seat, and vzAny is like a master event planner that fits everyone in way more efficiently.
And hey, don't just take my word for it. The official documentation is crystal clear. Using vzAny is the single most efficient way to apply a contract to all EPGs in a VRF. So you're not just making your own life easier as an admin, you're actually optimizing how the network hardware does its job. That's a huge win.
So how does ACI pull off this magic trick? Well, it's all about something called a PC tag, or policy control tag. Every EPG gets a unique PC tag number. Without vzAny, if your provider EPG is, say, PC tag 16401, you need a separate rule in the TCAM for it to talk to each consumer, 16402, 16403, 16404, and so on. That's 3 rules taking up 3 seats. But with vzAny, ACI is smart. It just creates one single elegant rule. PC tag 16401 can talk to PC tag 0. That special 0 is the identifier for vzAny, and it basically means match any PC tag in this VRF. And just like that, 3 rules become 1. That's how you save all that precious TCAM space.
Okay, enough theory. That's all cool, but let's get our hands dirty and see how you'd actually use vzAny in a couple of common real-world situations.
First things first, where do you even find this thing? Well, in the APERC interface, you don't actually look for the word vzAny. Instead, you go to the VRF you want to apply the policy to, and you'll find an object there called EPG collection for VRF. That's it. That's your vzAny object. And from there, you provide or consume contracts just like you would with any other EPG.
This diagram does a fantastic job of laying out the 3 main ways you'll see vzAny used in the wild to control traffic. Let's break down each of these scenarios.
So use case number 1 is the one we've mostly been talking about. vzAny is the consumer. You've got a single EPG, maybe a DNS server, that needs to provide a service to everyone in the VRF. Easy. The second case just flips that around. vzAny is the provider. Maybe you have a monitoring tool in one EPG that needs to pull data, like logs, from every other EPG. Perfect. And the third scenario is any to any. You just attach the same contract to vzAny on both the provider and the consumer side. This is awesome for something like ICMP, so anyone in the VRF can ping anyone else without a bunch of complicated rules.
Okay, this is really important. While vzAny is an absolutely amazing tool, it's not a silver bullet. You have to use it responsibly. There are some specific rules and limitations you need to be aware of so you don't accidentally open up a security hole.
All right, let's run through the big ones. First, when we say vzAny represents everybody, we really mean everybody in that VRF. That's your regular EPGs, your external L2 and L3 connections, and even any IP addresses that aren't part of some other EPG. Second, and this one is critical, especially for multi-tenancy, vzAny can be a consumer of a shared service from another VRF, but it is not supported as a provider. Let me say that again because it's a common mistake. vzAny cannot provide a shared service. Now, if you do use it as a consumer of a shared service, you're giving access to everyone in that VRF, so be careful. And finally, that TCM savings we talked about, you only get that if the contract scope is set to VRF or tenant. If you set it to application profile, it'll still work, but you won't get that awesome hardware optimization.
So, when you boil it all down, what's the big takeaway? vzAny is a fundamental tool for managing ACI policy at scale. It takes what could be a tangled mess of rules and turns it into simple, efficient, hardware-optimized group policies. It cleans up your config, saves critical hardware, and makes your whole network way more agile. So the question I'll leave you with is, how could using a tool like this change the way you think about your own network security and automation? Thanks for joining this explainer. We'll see you on the next one.